Lesson 9-5 we'll be talking about direct variation. A direct variation is a relationship in which the ratio of y to x is a constant k. We say y varies directly with x. So look at how we're writing that. We're writing y over x equals k. So in this case, we're going to be using this term direct variation, where so far we know that direct variation kind of, what we've talked about that in the past is that's our slope. So this is another way to talk about this is direct variation or just slope. So you look here thinking that k equals y over x. So in this problem, y equals 3x. If we divide both sides by x, we would cancel the x, and so I would have y over x equals 3. So now look at this, it says k equals y over x. Well, this is 3 equals y over x, so that means that 3 also equals k. So, and where k stands for your constant, and that what that means is it's a constant change in your graph, where the slope is a constant change always. You're always going up 3 over 1, up 3 over 1. And so this is just another way to think about it and talk about it. You can also write it as y equals kx, and you know we've normally been doing y equals mx plus b. So we're kind of swapping in a k for the m here. Whenever we talk about direct variation, instead of using the letter m, we think of it as a k. So let's take a look at this here. All right, it says find a constant ratio. The amount of money Serena earns at her job varies directly as the number of hours she works. So determine the amount Serena earns per hour. So we want per hour, so we always put x on the bottom. Okay, so at first we have 0, 0. She doesn't work at all. She doesn't earn anything. Okay, then as you look here, after working for 4 hours, she earns $40. Okay, and then after working 8 hours, she earns $80. All right, so these are equivalent ratios. Now let's go ahead and simplify them both down to what they stand for. So what this means is 10 to 1 because they want per hour. So $10 per 1 hour, or simply $10 per hour. Okay, so that's again, this would be your constant rate of change. So again, talking about direct variation. The total cost for cans of soup varies directly as the number of cans purchased. If 4 cans of soup cost $5, how much would it cost to buy 8 cans? Well, we can kind of set up a proportion to solve this here. We always put money on the top. All right, so I'm going to put 4 cans on bottom. So $5 for 4 cans, and that is directly proportional to the cost of 8 cans. All right, so we want to solve for x here. Well, notice here that you're doing, we're doubling the order here, so we're doing times 2. So you're going to do the same thing to the top. So x equals $10. So it'll cost you $10 for 8 cans, as long as there's a direct variation involved. You know, some places might give you a deal. If you buy more, you can pay a little bit less. So this is assuming that everything is proportional and equivalent, and you're going to pay $10 for those 8 cans. Determine whether the linear function is a direct variation. If so, state the constant of variation, or constant rate of change. So we need to determine whether this is a direct variation. If it is, then all of these ratios will be equivalent. So I'm just going to go ahead and write 16 over 2 equals 32 over 4 equals 54 over 6, and that equals 72 over 8. All right, so if I simplify this, I should get all of them to be the same. So 16 over 2 is 8 over 1, and this would also be 8 over 1. This here would be 9 over 1, because 54 times, or divided by 6 is 9, and 72 divided by 8 is also 9 over 1. Okay, so since this number changed right here, Okay, these are no longer equal. 8 over 1 is equal to 8 over 1, but it's not equal to 9 over 1. So these two here are equal. They're proportional, but these are not. So we would just say, no, there's not a direct variation. So there's not a direct variation. So this graph, you know, if we were to think of it like a graph, it's going to go 8 over 1 here, and then all of a sudden it's going to jump to 9 over 1. So you're going to see a slight increase in your graph there. So again, we'll do the same thing. Again, always put y on top. So 12 over 2, 25 over 4, 35 over 6, and 45 over 8. So let's simplify all these. It's going to be 6 to 1. If this was 24, I could say 6 to 1. However, 4 doesn't even divide into 25 evenly. So I know that right now it's not going to work. So I'm going to say no, not a direct variation. I see that, you know, if it was 24, if this was 36, and so on. So it's just a little bit off. Again, this graph actually is just going to kind of bounce around here a little bit like this. So there's not a direct variation throughout the graph. Again, we're talking about linear functions of straight lines. Okay, so proportional, remember the word proportional means equal. It is proportional if it goes through the origin. However, if it's here, if it's bumped down at all, okay, so if it has a b value, a y-intercept of anything other than 1, other than 0, okay, meaning the origin, then it's not proportional. Okay, if b equals 0, then it is going to be proportional. If it goes through the origin, your graph is going to be proportional. So you see here all the constant rate of change, the constant variations are going to be 2. Okay, here you see they're changing 5 halves, 3, 1, 3 halves. They're all different. So that kind of gives you your either proportional or non-proportional relationships. So the number of vehicles a dealership sells is directly proportional to the money spent on advertising. How many vehicles does a dealership sell for $1,000 spent on advertising? So here's advertising, and there's your $1,000. Here's your vehicles sold. Now this one's just a little bit different because I know we normally put money on the top, but in this case, your X value is your money. So they want to know how many vehicles does a dealership sell for each $1,000 spent on advertising. So what we need to find is we need to find a couple of intersection points here if possible. I see that's an intersection point right there, and it looks like I have another one right in there. Okay, so we need to find how this is changing. Okay, how many vehicles are selling here? We're going from 40 to 80, so that'd be 40 vehicles. Okay, and then I'm going from $5,000 all the way to $10,000, so that'd be $5,000 here. All right, or just simply 5. We can think of that as being 5, and we want to just simplify it down to 1. Okay, and we can do that because these are both divisible by 5 here, so 40 divided by 5 is 8 to 1. So for every $1,000 spent on advertising, the dealership sells 8 cars. So we can say 8 vehicles sold for $1,000 in ads. So, you know, you've heard the phrase before, you got to spend money to make money. This dealership has found out that if they put about $1,000 worth into advertisements, they usually can sell about 8 vehicles. All right, the power absorbed by a solar panel varies directly with its area. So if an 8 square meter panel absorbs 8,160 watts of power, how much power does a 12 square meter solar panel absorb? Well, I see here I have basically 4 items I need. I have this and this. They're both 8 square meters, 12 square meters. I have watts for my 8 square meter one. I need watts for my 12 square meter one. So I'm just going to set up this as a proportion to solve. So 8160 over 8. And I'm going to put my 12 on the bottom because these are both my sizes of my panels. And I'm going to solve for this x. So whenever you can set up a proportion to solve, go ahead and do that because we get 8x. And down here we're going to have 8,160 times 12, which gives us 97,920. So we have 97,920. And then we need to take that number and divide it by 8, get 12,240. So when we divide by 8, the 8s will cancel, x equals, and so what do we have there? 12,240. So 12,240, and the units are going to be watts of power. Okay. Now the reason we can do this is because we know that it varies directly. Okay, and varies directly, another way to say that is it is proportional or equal. Alright, so if we know that it's proportional or equal, we can set it up as a proportion and use cross multiply and divide to solve it. So to determine whether each linear function is a direct variation, if so, state the constant rate of change. So we've already done this as an example. Let's do 10 over 2, 20 over 4, 30 over 6, and 40 over 8. Always putting your y on top. So this can simplify down to 5. This is 5, and this is 5, and this is 5. So yes, the constant of variation is 5 to 1. Okay, and you'll want to write that as 5 to 1 rather than just 5. If you write it as 5, that's fine too. So again, here we're going to do 95 to 5, 190 to 10, 285 to 15, and we have 380 to 20. Okay, so we need to determine whether these are equal or not. So since these are a little bit bigger numbers, it's okay to just jump onto a calculator. We can do 95 divided by 5, and that gives us 19. Okay, so I have 19 here. I know that if I cross the zeros out, I'm going to have 19 here. So right now I might have a direct variation. I need to check the rest. So 285 divided by 15, that's also 19. So let's check the last one. 380 divided by 20, and that's also 19. All right, so I can just go ahead and finish this. I'll say 19 equals 19. And yes, constant variation is 19 to 1. And that would be my answer for that. Okay, for our last example, it says here, if y varies directly with x, write an equation for the direct variation, and then find each value. So it says, if y equals negative 5 when x equals 2, find y when x equals negative 8. Okay, so there's a couple different ways you could think about this here. Remember, our equation for direct variation is y equals kx, or k equals y over x. Okay, and so what they're doing here is they're giving us one of the two direct variations. So k equals negative 5 halves. All right, so that means it's going to go down 5 and right 2, down 5, right 2, down 5, right 2. Okay, and so what you could do here is you could set up a proportion. So you have negative 5 over 2, and that equals y over 8. Okay, and so you can cross multiply, divide, or you can see, okay, we're multiplying by 4. So then y is negative 20 in this case. All right, so that's one way to do this. Otherwise, if you wanted to just take this and substitute it in, we can make a new equation. We say y equals negative 5 halves x. And then that's the equation we're using for this one. So now we're taking 8 and substituting it into this equation. So we're using these numbers to figure out what k is by dividing by our x, we get negative 5 over 2. And now we're going to say y equals negative 5 halves times 8 over 1, which that simplifies to 1 and 4, which equals negative 20 over 1, which is negative 20. So either way you think about these two things, you're going to get the same answers. So whatever way you prefer, this way here I did it using proportions to solve. If you know y and you know x and you're only missing one of the 4 values, remember it's just y over x equals y over x. Direct variation means that they are proportional, so this thing should work as long as you only are looking for one item, and then you should be fine there. So that brings us to the end of our lesson. If you have any other questions, please watch the online tutorials, or be sure to check the step-by-step homework helper for all the odd problems.